Unit 2B, Organizing Data, Graphs. We're going to take the distributions we studied in Unit 2A and make pictures from those distributions. From this frequency distribution, we could make a number of different types of graphs. We could make, first of all, the bar graph. We usually put the x's on the horizontal axis and the frequencies on the vertical axis. Let me make a break here and put 0, 1, 2, 3, 4. And then on the frequencies are going up to 4, so I'll put 4 here. 2, 3, and 1. And now we would plot these points. 0, 2. 0, go up 2, right to there, and make a bar. 1, 1. Start with 1, go up to a height of 1, make a bar. 2, 4. From 2, go to a height of 4, make a bar. 3, 2. From 3, go to a height of 2, make a bar. And 4, 3. From 4, go to a height of 3, make a bar. Something like that would be a bar graph. There is something called a Pareto chart. And all that is you take the bars, make a bar graph, and you take the bars and you rearrange them in order. So we'll take this first, let's see, this is the highest bar. The highest bar is 2, so put 2 here, and we'll make a bar going up to 4, so something like this. Then the next highest bars would be 4 has a height of 3. So we'll put 4 here and make a bar going up to a height of 3. Something like that. The next highest bar would be 0, goes to a height of 2. So 0, make a height of 2. Then we have 3. From 3, also make a height of 2 for that bar. And then finally, for 1, make a height of 1. So that's a Pareto chart where the heights of the bars go down. They go in descending order. We could also make, from the same data, we could make a line graph, or it's also called a frequency polygon. And the way that works, again, x's on the horizontal axis and frequencies on the vertical axis. X's, this time I'll start with 0 at the origin. And the frequencies go up to 4 also. And now we'll plot the points. 0, 2, 0, then up 2. 1, 1. 1 in the X direction, and then up 1. 2, 4. 2 in the X direction, up 4. 3, 2. 3 in the X direction, up 2. 4, 3. 4 in the X direction, up 3. So we can connect those lines, and now we have a frequency polygon. We could also make what is called a dot diagram. Dot diagram goes like this. We make a line, horizontal line, and put in the X values, 0, 1, 2, 3, and 4. And then we use dots to represent the scores. So we have a score of 0. So we represent a score of 0 with a dot. I use big dots. That would represent a score of 0. But we have 2 zeros, so we make 2 dots, one piled on top of each other. So that represents our 2 zeros. That would be the 2 zeros. Now we have 1, 1, so you make a dot at 1. Then we have 4, 2, so you make 4 dots at 2, 2 dots at 3, and finally 3 dots at 4. So that would be a dot diagram. Here's a summary of the diagrams I just made. Notice the shape. This one happens to look a little bit like a W that's going uphill. Well, if you take the heights of these bars, you'll see it's got that same W shape. Or if you go to the dot diagram, you got the same W shape. The Pareto chart always goes downhill, so that's different. But we are going to be interested in the shape of the distribution. Here is the same data, but done with, in this case, Excel. So I put the data into Excel and made the bar graph. You'll see that same shape. And with Excel as well, made the frequency polygon or line graph. And this one over here was made with the TI-84. And you'll notice this same shape. For the cumulative frequency distribution, first thing you should notice is that these scores are always increasing as we go down. We could make a line graph from these data. So here is X, and here I'm going to put cumulative frequency. So we have 0, 1, 2, 3, 4, and then the cumulative frequencies go up to 12. So let me put 10 over here and 5. And now we'll plot these points. So 0 goes up to 2 right there. 1, and then go up to 3 right here. 2, 7, 3, 9, and 4, 12. Something like that. Connect these dots, and we have our cumulative frequency polygon. Also called an ogive. It's called an ogive because it has the shape of a Roman OG. An OG looks like this. If you ever saw a piece of furniture, maybe the edge of the furniture has has a piece of molding on it like that, or it's shaped like that. So this shape, this sort of an S shape, is an OG. So this sort of has that shape, not really too well, but what we're going to see, if we had a lot of data, you'll see the ogive usually looks like this. Next, we go to the relative frequency distribution. From this distribution, we could make a line graph or a bar graph. Let's make a line graph. So we go 0 to 4. On the x-axis. On the other axis, we'll put relative frequencies, and they go up to 33%. So I'll put 40% here. 20. You may have noticed that we don't have to have the same scale on each axis. They could be different. Now we plot the points. 0, 17%. So from 0 we go up to 17, about there. 1, 8% here. 2, we go to 33% there. 3, 17%, and 4, 25%. We connect those dots, you'll notice that the relative frequency distribution line graph, or polygon, has the same shape that we had before with our frequency polygon. They have the same exact shape, the W shape. A pie chart can be drawn from this relative frequency distribution. Let's start with the raw score of 4. That makes up 25% of the distribution. That would be 1/4 of the circle, so that would be 4. Now notice that 0 and 1 add up to another 25%, so we could make another quarter of a circle for those two. Most of that is going to be 0, so we'll put 0 here for 17% of the circle, and 1 for 8%. Then we have 2 is 33%, so 1/4 of the way around plus a little more for 2. And that leaves just 3 at 17%. So that would be a rough pie chart. It's very easy to produce all these graphs using machines. So that's what people do nowadays. Very rarely do people make charts by hand anymore. Here we have group data. Let's make a graph for the group data. I'm not going to start at 0. Let me start at -1. You'll see why in a minute. 0, 1, 2, 3, 4, 5. Let's go out to 6 for the x's. And for the frequencies, we go up to 6. So here's 6, and here is 3. Now, if we were making a bar graph, we would say the interval 0 to 1 go up to a height of 3. So 0 to 1 would be in here. And we're going to go up to 3. So you might make a bar going something like that. That would be a reasonable thing to do. Then for the next interval, from 2 to 3, we go to 6. So here's 2 to 3. Make a bar going up to 6. And then from 4 to 5, make a bar going up to 3. So you'd have this kind of bar graph. We can change this to a histogram. by making the bars get fatter until they touch. So let the bars get thicker and until they're going to meet and touch. So if these bars got thicker, this one got thicker, this got thicker, they would meet halfway. They would meet in the middle right here. So this bar would be this big. And similarly, it would move to meet this one, and they would meet in the middle. So this would be the middle bar. This bar came over and touched it, and it would increase by the same amount, the half a box on this side. It would look like that. And similarly, this bar would come over and touch this one, and it would increase by half a box this way, and we would have this picture. So now we have a histogram, looks like this, where the bars are touching. Here's a picture of what I just attempted. Notice that this graph has a certain kind of shape. It's sort of a mound shape, like that. It's also what they call symmetric. Symmetric means balanced, or one side is like the other side. This side looks like this side. If you folded this graph along this central axis, one side would land upon the other side. So it's symmetric. That's the end of Unit 2B. See Unit 2C for organizing data, the shapes of distributions.